Section 1. What is a mineral? A ruby, a gold nugget, a grain of salt look very different from one another, but they have one thing in common. They are all minerals, the basic minerals of Earth's crust. A mineral is a natural, usually inorganic solid that has characteristic chemical compositions, an orderly internet structure, and characteristic set of physical properties. Characteristic of minerals. To determine whether a substance is a mineral or a non-mineral, scientists ask 4 basic questions as shown in Table 1. If the answer to all 4 is yes, the substance is a mineral. First, is the substance inorganic? An inorganic substance is one that is not made up of living things or the remains of living things. Coal, for example, is organic. It is composed of the remains of ancient plant. Thus, coal is not a mineral. Second, does the substance occur naturally? Minerals form and exist in nature. Thus, a manufactured substance such as steel or brass is not a mineral. Third, is the substance a solid in a crystalline form? The volcanic glass obsidian is naturally occurring substance. However, the atoms in the obsidian are not arranged in a regularly repeating crystalline structure. Thus, obsidian is not a mineral. Finally, does the substance have a consistent chemical composition? The mineral fluorite has a consistent chemical composition of 1 calcium ion and 1 fluoride ion. However, basalt, however, can have a variety of substances. The ratio of these substances commonly varies in each sample of basalt. Kinds of minerals. Earth scientists have identified more than 3,000 minerals, but fewer than 20 of the minerals are common. The common minerals are rock-forming minerals because they form the rocks that make up the Earth's crust. 3 of these minerals are shown in Figure 1. Of 20 rock-forming minerals, 10 are so common they make up 90% of the Earth's mass. 90% of the mass of the Earth's crust. These minerals are quartz, orthoclase and plagioclase, muscovite, biotite, calcium, dolomite, halite, gypsum, and ferromagnetism minerals. Ferromagnesian minerals. All minerals, however, can be classified into two main groups, silicate minerals and non-silicate minerals, based on chemical composition of the minerals. Silicate minerals. A mineral that contains a combination of silicon, Si, and oxygen, O, is a silicate mineral. The mineral quartz has only silicon and oxygen atoms. However, other silicate minerals have 1 or more additional element. Feldspar are the most common silicate minerals. The type of feldspar that forms depends on which metal combines with the silicon oxygen atoms. Orthoclase forms when the metal is potassium. Plagioclase forms when the metal is sodium, Ca, or both. In addition to quartz and feldspar, ferromagnesian minerals, which are rich in iron, Fe, and magnesium, Mg, are silicates. These minerals include olivines, pyroxenes, amphiboles, and biotites. Silicate minerals make up 96% of the Earth's crust. Feldspar and quartz alone make up more than 50% of the crust. Ions and bonds. An atom that has a positive or a negative charge is called an ion. When an atom loses 1 or more electrons, the atom has more protons than electrons. Thus, the atom acquires a positive charge. An ion that has a positive charge is called a cation. All of the most abundant elements in Earth's crust, except oxygen, release electrons and form cations. For example, sodium, Na, atoms generally lose 1 electron to form a cation that has a charge of +1. An atom that gains 1 or more electrons acquires a negative charge because the atom has more electrons than protons. An ion that has a negative charge is called an anion. Chlorine, which generally gains one electron and thus has a charge of a -1, forms an anion. Atoms and ions rarely exist alone. Most atoms and ions combine to form compounds. Forces called chemical bonds hold atoms and ions together in these compounds. When ions combine to form compounds, the ions combine in proportions that allow all of the positive charges to equal and cancel out all the negative charges. Thus, the compound is electrically neutral. The mineral halite is a good example of this relationship. Because sodium ion has a +1 charge and chlorine has a -1 charge, one sodium ion bonds with one chlorine ion to form the compound sodium chloride, which is the mineral halite. Thus, 1 minus 1 equals 0, and the compound is neutral. Non-silicate minerals. Approximately 4% of the Earth's crust is made up of minerals that do not contain compounds of silicon oxygen, or non-silicate minerals. Table 2 organizes the 6 major groups of non-silicate minerals by their chemical composition: carbonates, halides, native elements, oxides, sulfates, and sulfides. Crystalline structure. All minerals on the Earth's crust have a crystalline structure. Each type of mineral crystal is characterized by a specific geometric arrangement of atoms. A crystal is a solid whose atoms, ions, or molecules are arranged in a regular repeating pattern. A large mineral crystal displays a characteristic geometry of that crystal's internal structure. The condition under which minerals form, however, often hinder the growth of a single large crystal. As a result, minerals are commonly made up of masses of crystals that are so small that you can only see them with a microscope. But if a crystal forms where the surrounding materials is not restrictive, the mineral will develop a single large crystal that has one of 6 basic crystal shapes. Knowing the crystal shapes is helpful in identifying the minerals. One way that scientists study the structure of crystals is by using X-rays. X-rays pass through the crystals and strike a photographic plate, produce images that show the geometric arrangements of the atoms that make up the structures. And that's as far as we are going with reading 1.